All right, so question number 20. The crew can no longer stand the captain's vast hat and vast ego. Avast! They set him adrift. There's a mutiny aboard the HMS Bounty. The crew decides to murder the captain rather than kill him outright. Um, you've read this already. The diagram is provided for us. I wanted to label all of the vectors of the information I'm given about the vectors. So HMS Bounty sails away, leaving the captain behind in the ship's boat. So here's the little captain in his little ship's boat with his vast hat, and he does not move. This whole entire problem, he stays put. The Bounty, the larger ship, sails away in the green direction, right? And so the problem tells me that is at a direction angle of 280 degrees. Okay. At the same time, the ocean's current is acting here in blue at 160 degrees. And on the red side, here's the resultant. We know where the ship is pointed in the one direction and the current is pushing in a different direction. So it's kind of like those problems where we watch the airplanes land in the crosswind, where it's like pointing off to the side, but actually moving straight up the runway. So the same thing is happening here. The ship is pointing in one direction, but the current is pushing it sideways. And so it moves in the red vector direction. And it tells us that goes 30 miles at a direction angle of 250 degrees. Okay, so it just labeled everything. The first question asked me if there's a right triangle present, and it kind of looks like maybe there would be, but I wanted to check all the possible corners of the triangle, so I subtracted the direction angles from the green and the red, which is a 30-degree angle, so that's not a right triangle. Between the green and the blue is 120, between the red and the blue, 90 degrees. So there's my right angle. I marked that. Afterwards, once I figured out that was the right angle, I marked that on to my diagram. Yes, it's a right triangle. How about vectors? Yes. So we can use a number of different quantities can be represented as vectors. Anything that has direction and magnitude. So distance is one example. We are given a distance of 30 miles, so definitely there are vectors here. We could, if we wanted, we could definitely find the velocity since we are told that it takes the boat, it takes the ship 2 hours to travel those 30 miles. We could calculate the velocity, and that would be possible. We could use that vector instead. At any rate, we're not asked what kind of vectors, just are there? Yes, there are. Is the resultant vector the hypotenuse? The resultant vector is here in red, and that is not the hypotenuse of the triangle. The hypotenuse would need to be opposite of the right angle, which would be the green side. So no. And then which would be the best type of vector? Well, there's two options, the same two I just mentioned. You could do either distance or velocity. Either one would be fine. Um, if you have the inside scoop of what the rest of the problem is going to ask you to do, then velocity actually will be a little bit easier. But you could mark either distance or velocity. They're both correct. Okay, well, since there is a right triangle and there are vectors, you have some choices. You could find vector components for the two vectors, the ship's direction and the current. Okay, you could find the x and the y component of each of those, add them together, or you could use the right triangle since we just established that there is a right triangle. Using vector components will take some more steps. Totally possible you can do that, but it's only one step to use the right triangle. I'm going to go with the right triangle. So, from the perspective of the marooned captain in the ship's boat adrift at sea, what is the inside the triangle angle? Clarification, inside the triangle angle always means from the perspective of the corner of the triangle at the origin. And in this case, it's going to mean the difference between the angle that the Bounty sails away at and the angle that actually it moves in. And so we calculated that already. That was the difference between the green and the red vectors, and so that was 30 degrees. Okay, so I brought that 30 degrees down here. If you subtract it the other way around, that's fine. You get negative 30, but we're going to enter our answer as a positive number here, so it's going to be positive 30 no matter which way you subtract. Okay, net speed of the HMS Bounty, that's the red vector in that diagram. So I am told it goes 30 miles and it takes 2 hours to do it. I remember that velocity is distance divided by time, so I divide to get 15 miles per hour. Next up is the green vector, the original speed of the HMS Bounty without the current. And so in my diagram, from the perspective of the captain, I forgot the little boat in this, I redrew this. but the green side is the hypotenuse, the red side is the adjacent. So if I use those two sides, I have two options for what ratio to set up. I could use cosine of 30, that gives me 15 over x. You could totally do that. I don't like have the variable in the denominator, so I'd go with the simpler algebra setup using secant of 30 is x over 15. Solving for x, my algebra is 15 times secant of 30. Gives me 17.3, but the directions ask me to round to the nearest whole mile per hour, so I'm going to call that 17. Since I have rounded that 17, I am not going to choose to use that 17 in my ensuing calculations, right? So here in the next step, I need to find the speed of the current. I'm going to use the red side of the triangle, which has not been rounded at all. I will get a more reliable answer as opposed to using the green side, which I just sort of rounded off. So this red side is the adjacent. That was the wrong pen style to choose. The blue side is the opposite side. I used z just to have a different variable. I don't use x twice in different places. That doesn't make sense. So using my tangent ratio is going to be the opposite over the adjacent. I could use cotangent, but tangent is going to give me the variable in the numerator, which is what I want anyway. So solving for z, I'm going to multiply 15 times the tangent of 30, give me 8.6, round that up to 9.